So that is, we are finding the number of mole of HNO3 with a given molar concentration 0.1 and the volume 22.60. I think that's how we settle that question. We move to the next question. Remember, all the question I have read it out, so this time around I'm solving. That's why I have my enough white paper with me at the time to solve. So I am going to question C1 now. Question C1. Make sure you take your time to watch the video very well so that you see the question, you check the question, you check the answers. I've also read the question so that we will not have any hindrance in solving the questions. So this time around, they say we should find the concentration in mole per dm cube. We want to find concentration in mole per dm cube of what? Of Na2CO3, that is our base. Truly, in the question, is our solution B contains sodium carbonate and sodium nitrate, but sodium nitrate is not visible. It's just like a trace to make the solution not to be pure. That's the reason. That's a trace of NaNO3 in the solution, but the main solution is sodium carbonate. So this time around, we want to find the concentration in mole per dm. That we want to find the molarity or the molar concentration. And remember, I should play back for you to know that we already have the following parameters. We have our VA as 22.60 centimeter cube. We need to know we have known our VB as 25.0 centimeter cube, and we want to find CB, but we have known CA, that is 0. I think that's 0.1 that we just got now. 0.1 that was given to us, 0.1 mole per dm cube. And likewise, we have our Na from the equation. Na from the equation, I'm referring to this. NaNB, I'm referring to this. NaNB. So this one is just spelling the given parameters here, but the one we need is here, the one from the equation, 1:2. So I'm having my Na as 2 and my Nb as 1. You still remember the formula CAVA over CB VB equals to Na over Nb. So what is my Ca? That is 0.1 times 22.60 over CB, that is unknown, times 25.0 equals to 2 over 1. When you cross multiply, you will be having 0.1 times 22.60 over 25 times 2. So we have CB equals, if you have done it very well, we'll be having 2.260 over 50, which means our CB, the molar concentration, is let's use calculator because of accuracy's sake. We have 2.26 divided by 50 So what was the answer? We have our answer as 0.0452 mole per dm cube. Achieved. We have achieved that. That is our molar conc or molarity of sodium trans-carbonate 4 is 0.0452 mole per dm cube. Alright, since I have enough space to permit me to divide this book like this, so that I will not be going far. Alright, I move to the next question. I think that is C2. Now, if you read back the question, the C2 said we should find the number of moles. We should find the number of moles, like the same way we did that of number of moles for acid the other time. So number of moles of Na2CO3, that's what we want to find. Number of moles of Na2CO3, that is, they mentioned 25 dm cube as the volume. That is, in this here, in my own environment here, we are using pipette of 25 centimeter cube. So without wasting time, we know N equals to CV, and what's our C? 0.0452 times 25 over 1000, 0.0452 times 0. If you press calculator, you have 0.025. So let me multiply all this together. So multiply all this together, you can see my answer. I have 1.13 times 10 power minus 3 in form of standard form, which means I'm having 0.00113 mole. So that settled that, and I'm done with that. And the next thing for me to find right now is to find, the next question says I should find the mass concentration of Na2CO3 in solution B with the given atomic mass. I will do that one here. I think that is question D. I will write it here. Question D, to find the mass concentration of Na2CO3. So, and since I want to find the mass concentration of Na2CO3, mass concentration can be maybe mass over volume, or it can come from the angle, since molar concentration is equal to mass concentration over molar mass. Definitely mass concentration will be molar concentration times molar mass. Now they gave me atomic mass: sodium 23, carbon 12, oxygen 16. So let me start by saying the molar mass of Na2CO3. I want to break it down because this is a classroom. So sodium is 23, and 23 times 2, plus carbon is 12, plus oxygen is 16 times 3. If you sum up everything together here, you are going to get 106 gram per mole. So that is the molar mass. And remember, we just finished getting the mass concentration of the base. So in that sense now, since molar conc is equals to mass concentration over molar mass, in that sense, mass conc becomes molar conc. In your own exam, you are a student, you will not write molar conc, you write it in full. But because I want us to manage time and everything, that's why I'm shortening. Molar concentration times molar mass. So which means I'm having this number 0.0452 times 106. So let me press calculator to get that. 0.0452 times 106. So here I have my mass concentration as 4.79 gram per dmq. We also achieved this. Remember, we've read all the question in the beginning. We don't need to read the question again to avoid wasting of time. So what are we doing right now is that we have settled this. Now we move to I think that should be the E part, to find the purity. Please do well to watch all the video, don't cut anywhere, watch from beginning to the end. If the video is too long, it will be divided into two videos, that is part 1, part 2, so that it will not be boring. It will be divided. So that is in case you are watching the video and the video just cut in the midway, do well to click the part 2 for the continuation. Percentage purity. So that one will be mass of pure over total mass of the sample, total mass of sample times 100. And what is the mass of pure? This is the mass of pure sodium carbonate, that is 4.79 over the total mass of sodium carbonate given the question is 5.5. So all times 100. So let's work with calculator. 4.79 times 100, answer divided by 5.5. So we are having 87. We are having 87 point approximately. We have 0.9, but let's say approximately 1%. So this is the percentage purity of the compound. The portion of sodium carbonate is 87.1, and the portion of sodium nitrate in that in this particular content that we use for titration. So this 87.1% is showing the percentage pure, the content, the main content of the sodium carbonate in this solution we use in the titration, while the remaining 12.9 is the impure part of it, or the impure sample in that particular solution B. So this is how we finish the question, and this is how we finish another video on the chemistry practical quantitative analysis that we call titration. We have released videos on it. This is another video that we just concluded. Another videos are still coming, both in all our science subjects, especially physics, chemistry, biology practicals. Before we talk about the theory, all what we need from you, just being there, turn on your notification button, do well to watch our videos, and like, share the comments, so there will be plenty in this platform. For now, I want to say bye, and I will be waiting for you in the next video. Bye.